Subtraction is the Achilles heel of, I think, well, everyone, but it doesn't need to be. I'm Annalise Record, and I'm an independent elementary math consultant. I live here in New Hampshire, but I travel the country working with educators and students to help create positive math journeys for every single student. The tagline in my consulting business is there is nothing elementary about teaching elementary math. I want to take just a couple of minutes right now to talk about subtraction and how we can build the flexibility and the efficiency needed, starting even with basic facts, and we can extend it to multi-digit numbers, fractions, and decimals. And I have an activity for you that I've been using in my consulting work. It's been really valuable to, as Christina Tondeville says, build our math minds so we can then help build the math minds of our kids. Now, I want to begin by talking first of all about a book I think every single educator and every pre-service educator needs to read. The book is by Dr. Rachel Lambert and it's called Rethinking Disability in Mathematics, a UDL math classroom guide for K-8. Now, I love this book so much that I actually made a t-shirt about my favorite takeaways from the book as a reminder to myself and everyone that I work with of what we can be doing to provide access in our classrooms for every single student. Now, this is not just a book for students who have learning disabilities. It's also for our neurodiverse students, our multi-language learners, right? Everyone. How can we be thinking ahead of time in our classroom lessons to provide access for the kids on the margins, thus including everyone on that journey? And I want to focus on subtraction today because I really do feel, as I'm traveling the country and working with teachers and students, that it is such an area of weakness. But again, it doesn't need to be. So what can we do? I'd like to begin by sharing with you the LESH translation model. Now, this is mentioned in Dr. Lambert's book, but also in the Principles to Actions book by the National Council of Teachers of Math, which I also highly recommend. These are 5 representations that we want our students to be exposed to in the exploration of all the math concepts, regardless of what grade level they're in. So take a look at this chart here. So the physical, now that's going to be the concrete manipulatives that we use in our classrooms. I love manipulatives within arm's reach of every student at all times, at all grade levels. The visual is the pictorial way we can make our thinking visible. Symbolic is using the numbers. I think we're all very familiar with the symbolic. The contextual is important as well, putting into context the variety of math concepts we are exploring with the students. And finally, verbal. Now, this is going to provide access for our students who have dyslexia, our students are multi-language learners, or even our neurodiverse students. So all 5 of these are really important that we're exploring all math content with. But you notice the most important thing are these arrows that are connecting all these representations. So it's important we're focusing on the connections between these representations and providing access for all of our students in these multimodal ways. Now, before we start talking about the thinking behind subtraction, we have to talk about the difference between strategies and models. So strategies are what we're doing with the numbers, and models are how we make that thinking visible. So our models are these representations, the concrete, pictorial, and abstract ways that help us express what our thinking was. The strategies are what we're actually doing with the numbers. I have a lot of teachers that will share with me they've been working on a strategy of, let's say, an open number line. But my response is always, well, what is the thinking that you're making visual on that number line? Let me show you an example. So we think about this example of 13 minus 8. Now we want to think about also in context. So this context I'm going to give you, let's imagine that I have 13 pencils and I give away 8 of them. Now there's action in that story that's reducing the number of pencils over time. In fact, we talk about that as a take from story problem within the world of cognitively guided instruction. Now, if I were to think about the thinking of the kids, when given a context like that, pretty often they will do something like this. They will count back that 8 one by one from the 13. So their strategy is counting back, right? But I'm modeling that on this number line, right? I'm showing that 13 and counting back 8. And I'd be curious if you can think about where the answer is on this model. So, right, it's going to be what I'm landing on. So I'm modeling this thinking of counting back 8 from the 13. When I'm showing that thinking, I'm landing on that 5. Now, another story context might sound like this. I have 13 pencils and Dan has 8. How many more would he need to have the same as me? Now, I have watched students solve that context very differently than counting back the 8 from the 13. They start with the 8 and they count up to find how far it is to get up to the 13. So subtraction has two different meanings. It's the amount we have left when we're taking things away, so things get broken and eaten or given away, but it's also the distance between the numbers, and I might think about adding up to find that distance. So let's take a look at that here on this, making it visual for you. So again, I'm using the same model of a number line. I'm starting on the 8, and I'm thinking about what I could add up to get up to the 13. But you'll notice also that I showed additive reasoning and not counting reasoning. I have a jump from the 8 to the 10. It's 2 more to get to 10, 3 more to get to that 13. So we can call this strategy finding the distance. And I'm wondering if you can think about where on this model does the answer lie? Right? It's up above. It's the distance between the numbers. Same model, a number line, but not only am I showing you a different strategy, right? I'm finding a distance strategy, but also showing you the difference between a strategy that's a counting strategy versus a strategy that is an additive reasoning strategy. We want to help move all our students over the course of K1 and 2 into this additive reasoning. So we certainly begin by the counting. We want to help move them into additive reasoning so they can be flexible and efficient and not only use this thinking with basic facts, but to extend it to larger numbers, decimals and fractions, and the integers in the middle school. It's a connected math journey. And so here's the activity. You'll be matching the cards on the left, which have the strategies written in words, and I'm specifying a certain model representation to make that thinking visible. On the right-hand side, those cards all have the visual images of these models, making that strategy visible. So when you get the activity and download it, you print out those pages and cut them apart. So then shuffle them. So you have the cards that have the named strategies with a certain model, and then you have all the visual representations of those models, making that strategy visible, and match them up. Now, you do have an answer key as well. So you'll notice on the cards, I specified the strategy, I specified the model. You'll see that I have some letters or numbers on the bottom of the cards. Those are you to match them up so you can see with the answer key whether you are correct or not. Now, in the activity, I've included 4 different subtraction strategies. There's the removing friendly numbers, the over strategy where we're kind of rounding a number to a friendlier number and then adjusting, the finding the distance between the numbers, and also the constant difference, which I haven't shown you visually yet, but it's keeping the distance between the numbers the same by either adding the same thing to both or taking away the same thing from both. And that will keep that distance constant, which allows us then to just change the numbers we're calculating with. Literally life-changing, particularly for mixed numbers and decimals and integers, crazy powerful. So I've also included a variety of models. So there's open number lines, there's Cuisenaire rods, 100 beaded number lines, and equations, just a variety of ways that we can make the thinking visible, the strategies that the students are using. So I hope you love the activity. Please let me know in the comments below or email me anytime to let me know how it goes when you use this with your colleagues, maybe even using it with your students. Together, we can help facilitate positive math journeys for every single student. So hopefully, subtraction will no longer be the Achilles heel of our students. Have a great day.